Okay.
Yeah.
Right now we are on practice 14. Everybody should have their practice 14 out. And I am working out number 1. That's what you guys had wanted to see, yes? All right. Yes? No? Did anybody say 1? No.
But we can start on that.
Yes? All right. Jane is making a rectangular garden. The length of the garden is 2 yards and the width is W. Is W in yards. Enter the function f of W, which describes the area in square yards of Jane's garden as a function of the width W. All right, so what is that asking us to do? All right, I'm going to read it one more time. Jen is making a rectangular prism. The length of the garden is 2 yards. Oh, I'm sorry, I did read it wrong. 2 yards greater than the width.
We have to make a note.
Okay, so if this is the width, and this is 2 greater than the width, what would I put? W plus 2 or 2 plus W, yes or no? All right, I'm going to read it. Jane is making a rectangular garden. The length of the garden, and I read it as just 2 yards. It's 2 yards greater than the width. Do we know how much the width is?
No.
No, so we just put W. So if this is the width, then the length is W plus 2 because it's 2 greater. Which describes the area. F of W is the area. What is the area of a rectangle? What times what? Length times width. So W times W plus 2.
We don't have to solve.
Nope, it just asked us to write the area, the function area. Function, where is it at? Function of width. Yes. All right. Questions? Musa, make sure you have this packet out. We're on practice 14. And we turned our progress reports in, so you need to make sure you get yours in.
Okay, I'll get it to you by the end of today.
Yeah.
All right. Okay, questions on number 1. Any others from 14? None? We can put it away. 11? A theater needs to place seats in rows. The function f of r, as shown below, can be used to determine the number of seats in each row, where r is the row number. Use a function to complete the table indicating the number of seats in each of the first 4 rows of the theater. So you're just plugging in here. F of 1 equals 8. And f of r equals blah, 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 blah. All right. Okay. I'm going to plug, okay, this is r. So I'm going to plug in for r. And I'm just going to change that to y. Equals f times, what is r? 8 minus 1. Plus 3. Function is shown below. Those seats in each row. For r is the number of rows. Okay, and I did plug the wrong number in here. Yeah, sorry. What should I have put here? 1. And I'm just going to set it equal to 8 and see what I get. F plus 3, 1. No, that's not going to work. Excuse me. Okay, well, we know when it's row 1, there's how many seats? 8. And how do we know that? Because what? Because it says right here that it is, oh, I'm sorry, right here that it is 8. A theater needs to place seats in rows. The function f of r is shown below. It can be used to determine the number of seats in each row, where R is the number of rows. So in row 2, it looks like they're just doing what each time? Adding 3. So what would it be for row 2? And then you add 3 and you get, and you add 3 and you get 17.
R minus 1.
I don't know. Do you guys, is this the recursive unit?
I believe so.
What I'm looking at it as is when you're plugging in row 2, this is row 2 minus 1 is row what? So you take the answer from row 1 and then you add it. For example, when you're doing row 4, 4 minus 1 is 3, so you look at 3's answer, add 3, and you get 17. Does that make sense?
Oh, that makes sense.
Okay. Again? You want me to say it again? Yeah. This is saying you take the previous row's answer and you add 3. R is the row. So R, the function, R minus 1, so you go to the previous row and you add 3. So when I'm on the second row, you go to the previous row, which was row 1, and add 3. 8 plus 3 is 11.
So you would plug in like 11, like say it was 8, you 8 minus 1 and then add the 3?
R is the row, yes. So R minus 1, okay, so let's look here. Let's say we're plugging in 4. What's 4 minus 1? 3. So you're doing f of 3 plus 3. What's f of 3? 1, 2, 3, that was 14, and 14 plus 3 is 17. So let me show you back with the first one. You plug 1 in for R. Well, they gave us f of 1, so let's plug in 2. You plug 2 in for R, what do you get? 2 minus 1 is, so you do f of 1 plus 3. F of 1 was 8. So 8 plus 3 is 11. So this is f of 2. So when you go to row 3 and you do f of 3, you do f of 3 minus 1. What's 3 minus 1? 2. So you do f of 2, which is 11. Thank you. Plus 3. Does that make sense? A little more sense now? Is that a yes? Okay, so using the previous answer and adding 3. All right. Any others? Are you guys okay if we start the next packet? Packet 15? Yes? Yes. Barb traveled 300 miles during the first 5 hours of her trip. Barb then traveled at a constant speed of 50 miles per hour for the remainder of the trip. Enter the function f of h, which describes the average speed during the entire trip as a function of time h in hours Barb traveled after her first 300 miles. Okay, Barb traveled 300 miles during the first 5 hours.
So it only have to be d equals r times 2.
We're going to use distance equals rate times time. Is that what you're saying? Okay. Barb traveled, blah, 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 blah. Barb then traveled at a constant speed of 50 miles per hour. So that's going to be, we'll figure that out later. For the remainder of the trip, enter the function f of h, which describes the average speed. So what is speed in here? Distance, rate, or time? So rate is a function of what? If I divide both sides by t, I get what? Distance over time. Do you agree if I'm solving for rate or my speed, I get distance over time? Yes or no? All right. Enter the function f of h, which describes the average speed, so the rate, during the entire trip as a function of time, h in hours. Barb traveled after her first 300 miles? What was that? Oh, excuse me. Okay, so how much did she travel in the beginning? 300, correct? Plus, how much does she travel after? Constant speed of what? 50 h, where h is the miles per hour. So 50 miles per hour. Does that make sense, depending on how many hours she's traveled? Divided by time after her first 300 miles. Good job. 5 plus h is correct, Chris. Good job.
Oh, thank you.
All right, are we ready for the next one? Which packet did I say I was to move on to? 15. Are we good?